Alright, it's time to talk about this little, talk about Pascal's triangle. If you guys don't remember what Pascal's triangle was, you used it to figure out something with polynomials or whatever. Anyway, it has an interesting secondary function, though. And I'm just going to start out by doing some of the triangle. So what you do is you start off with 1, and then you split in 1, 1. And then from there it starts making sense. 1 plus 0 is 1. 1 plus 1 is 2. And then 1. And I'm just going to keep going. 1, 3, 3, 1. And we'll just do one more level, because this is where the easy part of this trick ends. So 1, 4, 6, 4, 1. Okay. Now, if you look at each level and take it as a number, you get 1, 11, 121, 1,331, and 14,641. If you pick out a calculator and type in 11 to the power of 0, and continue on from there, 11 to the power of 1, 11 squared, cubed, and to the power of 4. That's what they actually are. So each of these levels, I can now just like a little 0, 1, 2, 3, and 4. So what you're seeing now is that each of these levels, at least these first 5, if you take them as their face values right across, that's 11 to the power of that row, starting with 0. So we get to the next one, it gets tricky. So I'm just gonna draw it out poorly. 1, 5, 10, 10, 5, 1. Yeah. I wrote the little 5 beside it, but 15,101,051 is not 11 to the power of 5. What you now have to do, this is where it gets tricky, it took me a bit to figure it out. These 3 digits here at the end, regardless of what's before, these 3 digits here are at the end of 11 to the power of 5. The rest of them, though, except for this, they have to be added together. So I'll just do it on this sheet. So start with 1, and on the next one we have 5 plus 1. So 5 plus 1 is 6, and it goes next to it. It goes to the next space. And then we have 0 plus 1, which is 1. It goes to the next space and put zeros above it. And then we have 0, 5, 1. And then fill in the rest with zeros. So 1, and then the 6, and then the 1, and then 0, 5, 1. 1, 6, 1, 0, 5, 1. So we end up with 161,051. And just to confirm, 11 to the power of 5, 161,051. Okay. So then we can continue this, and it gets a little strange. Yeah, I'm not even going to bother drawing this. Basically, 5, 6, 8, 9. Okay. You're seeing how this just gets really big. When you're dealing with all these, again, it's those last 3 digits. So on the 7, 171. As you can see, 11 to the power 7 ended in 171. And then before that, 5 plus 2, and 3 plus 5. 5 plus 2 is 7, 3 plus 5 is 8. So it's just to show you, it continues on that way. Because I don't want to draw those layers out and calculate them for you. Because this is where it gets messed up. It's still going to follow the same pattern. But when you get down to 11 to 9, you end up with some 3-digit numbers. And what you do with those, and we're going to start this off again here. Okay, so we have 1, 9 plus 3 is 12, and since that is greater, like we have to carry the 1 over, so where normally you would have this empty space here and then start here, you actually do that instead, because it's carrying the 1 over, and it's kind of weird, it's tricky, yeah, but now it's going to get even weirder. Okay, so 9 and 3 is 12. And it goes under there. And then 6 plus 8 is 14. So rather than starting here, of course, we carry the 1 over. And then we'll just fill in the zeros ahead of time. Now the next one you see 4, but then there's 126 is the next number. So it's not just a 2-digit number anymore, where we just had 8 plus 5 is 13, and then that adds on there, blah, blah. What you have to do is you have to isolate that 12 out of the 126. So 4 plus 12 is 16. And so, yeah, you have to do that. Yep. Okay. Just making sure I'm not getting lost in this. So then we add zeros, and then we have the same, no, sorry, we have 18 here. So then 18 goes all the way up. And then we're back to 14. It's just going to be the same basic thing as here. No, sorry, it reverses. Anyway, I'm just confusing it. I'm making it even more confusing. So 6 plus 8 is 14. And zeros all the way down. And then 4 plus 3 is 8, or 7. See, now I'm fucking up the math altogether. 7. And then again, these last 3 digits are saved. And 6, 9, 1. 0, 0, 0, 0, 0, 0, 0, 0, 0, yada, yada, yada. You get the point. Then 1, 9, 6, 7, 4, 9, 7, 5, 3, 2. So we have 2,357,947,691. And sure enough, 11 to the power of 9. 2,357,947,691. So yeah, that's something Pascal's triangle can do, and I haven't gotten to 4-digit values in here. But I imagine it'll probably be the same, except for instead of the 12 and then the 6, let's say there was like a 1 after that, it would be 12 and then 61 or something. I'm probably going to try it at some point, but enough math for tonight.